my amazing students, this is Mrs. A, and I'm back here with the last little bit of our second test material. We're doing 4.3, and we only have 2 problems to do on 4.3. Remember that on 4.3 we are not doing Bayes' theorem. So basically once you hit Bayes' theorem you can stop in that chapter. So we're only doing 2 homeworks. The first one is exercise number 7. And this one is very simple because we're doing the probability of at least one girl. Here is number 7, births in the United States. In the United States, the true probability of a baby being a boy is 0.512 based on the data available at this writing. Among the next 6 randomly selected births in the United States, what is the probability that at least one of them is a girl? Okay, so basically what we're going to do, we're trying to find the probability of at least one girl. So we were given that the probability of a boy is 0.512. The probability of at least one girl in 6 births is the question. So the first thing we're going to do is find the probability that they are all boys. So we have 6 randomly selected births. We're trying to find the probability that they are all boys. And in doing so, we are going to multiply 0.512 times itself 6 times. So we're going to raise it to the 6th power. And then to find the probability of at least one girl, remember the probability of at least one girl is 1 minus the probability that there are no girls, which is the probability that they're all boys. So 1 minus the probability that they are all boys will be the probability that there's at least one girl. So here's the math. When finding the probability of boy, 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 or 0.512 raised to the 6th power, because remember we just take 0.512 times 0.512, ... And we end up getting 0.01801 when we do that math, and then we take that away from 1, and we end up getting 0.982. So we have a fairly high probability, a very high probability, that at least one will be a girl. And that is all there is to problem number 7. And the answer in the book just says 0.982. Okay, so in number 13, which is our second and last problem in this set, we have a chart right there, and we're supposed to use this chart on the denomination effect. So on A, it says find the probability of randomly selecting a student who spent the money given that the student was given 4 quarters. In part B, we're supposed to find the probability of randomly selecting a student who kept the money given that the student was given 4 quarters. And in C, we're supposed to find out what do the preceding results suggest. So here's the board where I wrote the answers. So on A, we were supposed to find the probability of spent given we had 4 quarters given to us. And I found the probability, which I will show you how we did that in just a minute. And it was 0.628. On the second probability, I find that, and I'll show you how in a moment, and it's 0.372. So I said that my results were that it was much more likely to spend than to keep 4 quarters. But now let's get nitty-gritty on how we get those answers. So in part A, we're supposed to use the formula probability of B given A is equal to the probability that A and B both happen, divided by the probability that A happens. So in A, we're going to find the probability that it was spent and 4 quarters, and divide that by the probability of 4 quarters. And then when we look at our little chart, we want the probability that it was spent and 4 quarters, and that is going to be the spent column, which is right here where they purchased the gum, and 4 quarters. So there's only 27 that meet both requirements. So 27 out of a total of 89. And we have that right here. So 27 over a total of 89. And then on the bottom, we're going to have the probability of 4 quarters. Okay, so going over here to our chart again, we have the probability of 4/4 would be the 27 added to the 16, that's 43, and then dividing all of that by the 89 total of all of them. So here is the calculation here. So we have the numerator, the denominator. When I do that math, the 89s just disappear because they end up canceling each other out. I get 27 over 43, or 0.628. So now we look at the B portion, doing the probability that they kept the 4/4 when they were given 4/4. Okay, so the top is going to be the probability that they kept it and it was 4/4. And when we look at our little chart, we have 4/4 and then we have kept. Okay, so there was only 16 out of 89 that were kept. So we're going to note that here, 16 out of 89 is kept and 4/4. And then the denominator is the probability that it was 4/4 again, which is the same thing we had at the bottom of the other board, which was just 43 over 89, which we get from here, 4/4. So we have 27 and 16. We add them together, we get the 43 out of 89 total. So this is my B calculation here, and I wind it with 0.372, which is not half of the other one, but quite reduced from the 0.628. And these are the answers right out of the book. It appears that when students are given 4/4, they are more likely to spend the money than to keep it. That is your homework from 4.3. So as you're preparing for the test, remember to go back to your homeworks, prepare all the things that we did in the book, but you're also responsible for anything that I gave you online through the homeworks there. So have fun preparing for your test. I'm done with the videos, and tomorrow when we get to class, I will cover a little bit of the rest of 4.2, cover 4.3, might even start 4.4, which will not be on your test. So your test is going to be all of chapter 3, 3.1, 3.2, 3.3, and then 4.1, 4.2, 4.3. And this is Mrs. A, and may God bless your day.